Hi guys, I'm Lebogang. I'll be doing an example which is not in the module about escalating payments. The example reads as the machine has a scrap value of 9,500 and will cost 55,000 to replace in 6 years' time. A sinking fund is to be established into which deposits will be made at the end of each month over the 6-year period. These deposits will escalate annually after every 12 deposits by 10%. At the end of each month over the 6-year period, an amount of 250 will be withdrawn to pay for the maintenance of the machine. The deposits into the fund must allow for the maintenance payments and accumulate the difference between the purchase price of a new machine and the scrap value of the old machine in 6 years' time. The fund earns interest of 13.25 compounded monthly and it's tax-free. Determine the first payment into the fund. As the example said, it's tax-free, so we don't have to calculate the interest before tax or after tax, like I did here. So the timeline is already drawn. Like they said, it's 6 years. So after 12 months, my timeline is in months, so it's 72 months. Okay, so the first month, it will just be a payment of P, and then from the 13th to the 24th, it will be 1.1 P squared, and then skip, and then it goes on like that until the 6th year. It will be 1.1 to the power of 5 P, and the 250 that has to go out. Okay, then we calculate a future value. In order to calculate our future value, which will be our accumulated payment, we say the 55,000 minus the 9,500 to give us 45,500. Okay, so we've already converted the interest rate into per month by just divided by 12. As we're told, there's no tax. Okay, so because it's an annuity and the 250s are paid every month, we will say this will act as our future value. And then, so it will be 45,500 plus the annuity of the 250. And it's 72 because it's 72 months. So that's why even your interest and your months need to correspond. Therefore, here it has to be a geometric sequence in order to solve the whole equation. So therefore, it will be the first year, which will be the future value of the annuity plus what is left, because this serves as our focal point. And then plus the second year. This 60 comes from 72 minus the 12, which will give us 60. And this is the second, so it will be 60 minus 12, which will give us 42, plus so on. And then the final year will only be 1.1 to the power of 5 and the future value, but no added bracket because it's the end. Therefore, okay, if you calculate this on your calculator, the financial calculator, using your compound function, and your set will be end, the number will be 12, and then your interest will be 13.25 divided by 12. And then your future value will remain as 0, and then your payments will be 1, and then your future value, it will be 0, but then that's what we're looking for, the future value. So then you press solve. That's how you will get this amount. Oh, sorry, no, I made a mistake. So let's start again. It's compound, and then it's end, and then it's 12, and then it's 13.25 divided by 12. And then future value is 0, and then the payments are 250, right? And then the end is 72. And then we just look for our FV, and then this is how we're going to get the 27,278,79901. Okay, and then here we take up the P, and then we form a geometric sequence. So then this is what remains within the bracket. So then, because it's a geometric sequence, we're going to take Sn is equal to A and 1 minus R to the power of n over 1 minus R. This, because it's a geometric sequence, it's our first sequence, which serves as our A. So it's going to be A, this is our A, and you get it by compound end, that's actually the one that I was doing, then 12 divided by the interest, which is 13.25% over 12, and then your future value is 0, your payments 1, and then we're looking for our future value. And then you say solve, and then you're going to get the 24.65280099. And then your R, if you guys remember, our R, we got it by term 2 over the term 1. So this is our first term, this is our second term. So therefore it's going to be the second term, which is 1,1 s squared angle 12i plus I to the power of 48 over the first term, which is s angle 12i plus I to the power of 60, which is equal to 1,1 plus 1 plus I to the power of minus 12, because these two will cancel out, and it will be 48 minus 60 to give you the minus 12. And then, okay, we come this side. So therefore, the Sn, going back to this formula, you got your A as the 24, and then it's going to be 1 minus this. This you can calculate on your normal calculator. Okay, so, okay, I know you guys know how to do that. And then it's going to be the 1 over the R that you got, this R, and then you get your answer. And then how we got the 72,778 was by adding the 45,500 plus 27,278,79901 to get the 72,000. And then the P that you took out and the S in. And then it's going to be, then you just divide. Then it's going to be P is equal to 72,78,79901 over 135,291,1429 is equal to 537,95, which is your first payment. Thanks.